the Go with AAUW. I'm your host, Lisa Schaefer. Today we'll be talking with three girls that I met at a science fair this spring. The first girl we have is Megan Langerman. She is a junior at Woodson High School. And we have Kirsten Bennett. She's a junior at Fairfax High School. And we have Jackie Birnbaum, and she's a sophomore at Falls Church High School. And all three of them did very excellent science fair projects. I selected these three girls because not only of the quality of their project, but also because they could speak very well about their project. So first, let's have Megan tell us a little bit about her project, and we can ask her some questions about her project while she's talking about it.
Well, I developed a homemade wind turbine to test 4 different blades at 3 different angles to the prop. I tested it at 15, 30, and 10 degrees because I want to see which one caused the blades and the whole system to be most efficient.
Okay.
I used balsa wood to cut out the propellers, and I connected it to a Tinker Toy hub. I used a CD as the tail, and the whole system is made out of PVC pipe, which was very easy to handle and just cut to the shape.
Where did you get the idea for the particular shapes of each of these blades? Because they're all different, aren't they?
Well, there's 4 different designs.
Okay.
And I developed them after studying like what is used on most commercial wind turbines, and I developed the ideas mostly out of pure luck.
And how did you find out about what commercial wind turbines look like?
Oh, it's all on the internet. They have many sites that show their propellers so that when businesses or people want to buy them, they can research which design they want, which was most efficient for their jobs, and which would be best for the community.
Okay, great. Mm-hmm. Okay.
And I used a multimeter to measure the voltage output of the system, and I measured it in millivolts because it was obviously a very small output. There's a small generator located in here that measured the efficiency of the blades after they were being turned by a home fan.
Okay. Okay. And so, what did you learn from this project?
The blade design that is on the propeller right now was most efficient. It put out about 97 millivolts, as opposed to the least efficient one, which put out about 47 millivolts at the most shallow angle, which was 10 degrees.
Okay.
And that was the most efficient for the whole system.
Okay.
How did you think of this? Like, what made you think of the idea?
My grandparents live in the Midwest, and their town is actually powered by a wind turbine, so it really inspired me to get into it and find out more about it, because there's these huge, massive wind turbines, and I really wanted to learn more in depth about it.
Do you plan on continuing this project next year, maybe?
Yeah, I developed a 2D design because I didn't know where to start with the whole thing. Next year I want to take this design and go 3D with fiberglass and a hollow cavity, so it's more like a commercial wind turbine.
Wow. So this is just 2 dimensions. It's just a flat piece of balsa wood.
Yeah.
And so next year you're going to shape plexiglass.
Oh, fiberglass.
Fiberglass.
Because
okay.
it's lighter weight and it's durable. And then I can play more with the airfoil, which is the drag that each blade has as it moves around, so that it's less wind resistant, but it's more effective when turning the generator, and has a greater output of energy.
Great. Wow. That'll be interesting. Do you know how you're going to shape the fiberglass yet?
No, I have to study more about the effects of wind as it flows over the blade and the curves on each different part, because you want more of a curve on the lower part because that's where most of the push is, but you want a flatter surface out here because that's where most of the torque comes as it moves around the system, because the longer the blade is, the easier it is for the props to move around, but you don't want the resistance to be too great out there.
And how much did you know about wind turbines before you started this project?
Honestly, I didn't know very much. I had to do so much research just to figure out the setup, how much was involved. Just building it, I had to figure out what systems to put together, like the ball bearing turning system, which allows the whole thing to move around, the rotor, the tail. I had to figure out everything.
And why did you want this to be able to spin?
That allows in real life, the wind turbines are built so that they can turn into the wind to become much more, they can capture the greatest amount of wind energy.
Okay.
So this allows the whole system to move, because if it faces directly into the wind, it actually uses the least amount of energy.
Right. So with your experiment, you just used the fan, so if you happen to move the fan,
That would move wherever it wanted.
Okay, great. Okay, well, Kirsten, let's hear a little bit about your project.
Okay, well, my project was about wetsuits. I used neoprene wetsuits, which are popular for surfing. My dad actually surfs, so I got the idea kind of from him. And this is really the starting point for my experiment. Next year I hope to expand it. What I did was I tested the effectiveness of the temperature and how it would maintain body heat. I started with a plastic bladder, and I put water into it at about 103 degrees Fahrenheit. I used that as my control, as if it was a human going into water without any protection. What I did was I stuck the bladder into the water, and the water was at about 53 degrees Fahrenheit. And I did this for 9 minutes, and I recorded the temperature over that 9-minute period. And there was a drastic change. There was 38 degrees lost in a 9-minute period.
Oh, wow.
And then I did the same procedure, but I placed the bladder into the sleeve of 3 different wetsuits, a 1 millimeter, a 2 millimeter, and a 4 millimeter. And then I did the same thing, a 9-minute period. And it was a significant difference depending on the thickness of the wetsuit. Over the 9-minute period, the 4 millimeter wetsuit only had 5 degrees lost of body heat, which is
That's great.
Yeah, a lot
That's
better.
what you would want.
Oh yeah, definitely. So I was really pleased with the results, and that's what my hypothesis was. I hypothesized that it would, in fact, be the best.
So you just didn't know how much the difference was going to be until you tried it.
And then also I wanted to create a simple at-home method to test the wetsuit effectiveness.
Did the instructions on the wetsuit say anything about how much body heat would be lost, or was that just something you found out through experience?
Not on the wetsuits, but there's on the internet you could see about the range that it was meant to be in.
Okay.
And actually 53 degrees was drastic for each of the wetsuits. I mean, the 1 millimeter you want to be in about 70 to 80 degrees of Fahrenheit of water. So I did it drastic so that I could see over a 9-minute period a big change.
Right. Okay.
What made you choose neoprene wetsuits?
Neoprene is, right now it's the best, it's the most effective. What happens is when you enter the water, a small film, like filter of water goes into the wetsuit, and your body heat will warm that, so you don't feel the effects of the water. And right now that's the best material out on the market. But next year I hope to test new materials and maybe find a material that works better and that would hold in body heat even more.
Okay. And you were in the engineering category when I was judging your project. So why were you placed in an engineering science fair category as opposed to something else? And what made us an engineering project as opposed to something that
Right. Well, what I did was after I collected the data, I applied Newton's law of cooling to get statistics and see exactly how it was supposed to cool over time. And after I applied Newton's law of cooling to each of the averages, I was really excited to see that my averages that I had in experimentation were what was calculated. There was about maybe a 0.1 deviation from the equation. So it was really exciting, and that's why it's engineering, because not only did I engineer a method to test wetsuit effectiveness, but then I used statistics and other equations to derive it and to see the effectiveness and the soundness.
And your project was also in the engineering category, and so why was yours placed in that category?
Well, I was able to get numerical data out of my project and apply it to real life so that it would be useful and applicable in a proportional size. My project's obviously much less or much smaller than it would be in real life, but it's able to be proportionally multiplied by a number.
Right, yes. And you also did have an experiment designed where you tried different levels of, like, different blade designs, different angles, and so it was a designed engineering experiment.